So remember we learned mean and variance. So this is natural to consider mean and variance of a random variable. So expectation or the mean is you just calculate the weighted average of all the value and which weight is probability. Okay, there's a weighted average because the weights are probability, right? And the probability sum to 1, so the denominator will be 1. Okay, so it's a standard weighted average problem. So usually we denote the expected value of x to be mu of x. Okay, and variance will be, as we see, is a square difference from the mean. Again, it's a weighted mean, right? It's a weighted mean, and then you weight it by the probability. Okay, if again the denominator will be up to 1, so that is a mean of the square difference. Okay, so this is what it means. Okay, so usually we denote by sigma square. Okay, so let's look at the example. Okay, so a wrong die, a fair die, is we have seen in before the example, we have outcome 1 up to 6, right? Each outcome is equally likely, so it's up to 1, so each one is 1 over 6, right? So that's why we have 1 times 1 over 6 and 2 times 2 over 6, 3 times 1 over 6 up to 6 times 1 over 6, and the average would be 3.5 as we would have expect. So that means what does that mean is if you try to have a repeat this random experiment many times, okay, and what is the average value, okay, of the random variable, because each outcome can be converted to the random variable, right? And then, for example, the first row is 1 and second time row is 2, and then you average all this thing up, then you should expect the outcome is 3.5, right? So that is what it means by expected value, is what is expected to be. And the variance will be how the mean difference from 3.5, right? Suppose you can have 1 or 2 or 3, the square difference, okay? A square difference from mean. What is if you roll many times, the outcome, and you take them different from the mean and square it, and you would see is likely to relate is close to 2.91. So the calculation is 1.1 minus 3.5 square weighted by is probability 1 over 6, and same for 2 up to 6. Okay, this is how we would use mean and variance for a random variable.